In section 7.3, we're going to look at similar right triangles that are formed when you draw the altitude in a right triangle from the right angle. And here's a picture of that. If the altitude is drawn to the hypotenuse of a right triangle, so this original right triangle, if I draw it in altitude from this vertex at the right angle down to the hypotenuse, three similar triangles are actually formed. And hopefully you see all three triangles. We're talking about this green one that I highlighted here. And we do have the green triangle being a right triangle, this orange triangle, and then the entire big triangle. First of all, why are they similar? Well, if you take a look, they all have a right angle. The green triangle has a right angle, so does the orange triangle, and here the big triangle has a right angle at its vertex C. Now they only need one other angle to be similar. Remember that angle-angle similarity is enough to show that triangles are similar if you have two congruent angles. Well, look at the green triangle compared to the big triangle. They have an angle in common. They share an angle. This green triangle has angle A. Doesn't the big triangle also have angle A? So now you have angle-angle similarity between the green triangle and the big triangle. And then look at the orange triangle and the big triangle. They share an angle as well, angle B. That's part of the orange triangle. It's also part of the big triangle. So they are similar by angle-angle similarity. And I want to name those similar triangles. I'm going to start out with that green triangle, and I'm going to name it, how about I do ADC? Forgot my triangle symbol. Triangle ADC. And I'm going to say is similar to, and I'm going to use black to name the big triangle. Well, first of all, you need the vertices to correspond, right? So angle A was the one that the green triangle and big triangle shared. A came first. So then when I name the big triangle, I'm going to do A first. Now for the green triangle, D was the right angle of the green triangle. So now I need the right angle of the big triangle, which is at C. And the last vertex of the big triangle would be at B. And that's also similar to this orangish triangle. How am I going to know how to name that? Well, what angle did the orange triangle and the big triangle share? Remember, this is the big triangle here. Well, the big triangle and the orange triangle both had angle B. B was the last letter, so better be the last letter here. The right angle of the big triangle was at C in the middle, and the right angle of this orange triangle is at D, so that letter's going in the middle. And C would be the first letter I'm going to list. So it's kind of nice to be able to look at the angles that they share, each of the smaller triangles with the large triangle, and look at where the right angle is located, and then you can name those similar triangles. So it's cool. You got three similar triangles, similar because of angle-angle, and we're going to look at setting up proportions, finding unknowns using this. One thing that you should be able to do is identify similar triangles from any sort of sketch or orientation of this. Again, we have one big right triangle where the altitude is drawn from the right angle to the hypotenuse. So all three triangles formed are similar. When it says sketch them in the same orientation, you're basically going to redraw all of these, but turn, rotate, make them face and look the same. I'm probably going to keep the same orientation of the big triangle, so I'm going to try to do a triangle the same size as that big one here. I know this is not perfect. It's close enough. The big triangle was EDF, and the right angle was here. And I'm going to try to imagine taking this little triangle and, I guess, rotating it and flipping it, because I got to put DG would be the shorter leg, just like it's the shorter leg of the big triangle. So I'm like flipping this around. So that DG would be here, and then that other leg is going out this way. So they are the same orientation because the right angle's in the same spot. And now I got to label this correctly. Well, G is the right angle of that little triangle. D would be up here, and E would be this vertex. And then finally I got to draw this triangle in the same orientation. So G is the right angle there, and GE was the shorter leg, so that's going here. Trying to make these approximately the size they actually are. Now, if this triangle G was the right angle, and E was the shorter leg, and F would be this vertex out here. So again, imagining this one, you'd have to flip and make this right angle vertex go down, as it did here. So we sketch them in the same orientation. Now I have to identify the similar triangles, so I'll kind of do the same thing I did before. First, let's do the little triangle. And I'm going to name this kind of however I want, but maybe I'll do DGE. And then let's do the big triangle next, because I think that's the easiest way to do it. Because if I look at DGE and I look at the big triangle, they shared vertex D, right? D was an angle in both triangles, this little guy and the big one. So D came first, it'll come first again. In the green triangle, I did G, which was the right angle of that little triangle next. For the big triangle, the right angle is at E, and the last vertex of the big triangle is at F. And that's similar too. We're going to do the triangle on the right, or the medium-sized one. How am I going to name that? Remember how I kept doing the right angle in the middle? And the right angle of this one is at G. So that's going to be the middle letter, just like E was the right angle of the big one, and G was the right angle of the one on the left, the little guy too. Alright, for the big triangle, what angle did it have in common with this triangle here on the right? Well, doesn't it have angle F? Because that's part of the big triangle and this one on the right. So F goes in the same spot. And the other vertex I'm missing for the triangle on the right is E. So I identified the similar triangles and I sketched them in the same sort of orientation, visualizing what they would look like if I flipped and rotated them to look the same. Alright, here's where we get to the good stuff. We're going to use these similar right triangles to set up proportions, and we're going to find the values of these variables. Now, the way that I keep everything straight and get to the point where I can set up these proportions is name the parts of each right triangle as either the shorter leg, the longer leg, or the hypotenuse. Because each of these right triangles is going to have those things in common. So if I look at one triangle and I do short leg and hypotenuse, then for the next triangle I'm going to have to do short leg and hypotenuse. Just make sure that you're constantly keeping track of what parts you're dealing with. So let's say that I was going to try to find x in this triangle. Obviously, this is the way I start. I mean, obviously I'm going to have to find x, so I'm going to be using x somehow. So I'm going to start with that in my proportion. And then pick a number that's also in the same triangle as x. And if you think about this side right here that x is, it's actually in two different triangles, because x is in both this triangle here and this triangle here. Both of the smaller ones, not the full one. So you have a choice right now, because what side is also given in this triangle? Well, 3. And what side is also given in this triangle? 4. It's up to you what side to pick, what triangle. Just to pick, I'm going to pick 3. Now if I pick x with 3, x and 3 are both in this triangle right here. Now I have to identify, am I talking about the shorter leg, the longer leg, or the hypotenuse for each of those parts? What is x for this triangle? Is it the shorter leg, longer leg, or hypotenuse? Well, it's definitely a leg because it's next to this right angle, and I would say it's the longer of the two legs. So I'm going to put LL for long leg by the x. What is 3 for this triangle? 3 is the length of the hypotenuse for that triangle, so I'm going to put an h here. I think it's critical to put these letters because it helps you out a ton. Because now you're going to have to pick a new triangle here, and you're going to have to pick the long leg and the hypotenuse of that triangle and put the correct numbers here. But now I know what to put there. I guess the question is, what triangle do I have the long leg and the hypotenuse for? If I look at this triangle here, I actually don't have the longer leg. This would be the longer leg of this partial triangle, and I don't know that. I know the whole thing is 5. So the triangle I'm going to have to use here is the full triangle. So I'm going to use this entire triangle. I'm really good at drawing some of these lines. Okay, I'm going to use that green triangle, and I have to put long leg on top. What's the longer leg of this big green triangle? The longer leg would be 4. hypotenuse goes on bottom. What's the hypotenuse of this big triangle? Would be 5. Okay, so putting everything in the right place is the hard part. Now this solving is going to be pretty easy because you're just cross multiplying. But make sure you're labeling what you're dealing with there. If I cross multiply now, I get 5x here, and 4 times 3 is 12. Divide by 5, and 12 divided by 5 would be 2.4. Okay, so setting it up, I had picked a number that was in the same triangle as x, figured out what parts those were, and found those parts for a different triangle to find my variable. Okay, let's try the next one here. Again, if I want to find h, I might as well start with it. Now pick a triangle that h is in. Well, h is in both of these triangles, so it's up to you which one you want to use. Maybe I'll look at this little triangle. I feel like it. Alright, if I pick the little triangle, what other side is in that triangle with h? Well, it would be 5. H and 5 are both in this green triangle. And now identify, what parts do we have? What are h and 5? Are they the shorter leg, the longer leg, or the hypotenuse? H in this case is actually the longer of the two legs, right? Because these are the two legs. It's the longer of the two legs in that right triangle. 5 for this right triangle is the hypotenuse. So I picked the long leg and hypotenuse of one of the triangles. I'm going to have to pick long leg and hypotenuse of a different triangle. What triangle do I have long leg and hypotenuse for? Well, actually, I have everything for the big triangle, so let's use that. If I use the big triangle, I need the long leg of the big triangle first. And here's my two legs of the big triangle. The longer leg is 12. I need hypotenuse on bottom. What's the hypotenuse of this big triangle? Well, it's this whole side, which is 13. Okay, so we did the hard part. You look at the similar triangles, you make sure you're picking corresponding sides by deciding whether you have short leg, long leg, hypotenuse. Do the easy part now and cross multiply and solve. 13h equals 5 times 12, just giving me 60. And then I'm going to divide by 13. And I determine that h is 4.62 if I round to 2 decimal places. Okay? So there's our first example with these similar right triangles. There's also some geometric means that show up with these similar right triangles. If you remember geometric mean, they have the same variable in the means positions. So in this case, f was in the mean position, so it's going to go here again. In this case, a was in that mean spot, and so a is going to be here again. And in this case, b is in the mean spot, so it's going to go here again. So that's why it's geometric means, is because you see the same variable show up diagonal from itself. Take a look at the diagram once. So A isn't the original leg of the big triangle, B is the other original leg of the big triangle, C is the original hypotenuse. I've split this side now into parts D and E, F is the altitude. So if you're gonna help me here figure out what to fill in for these blanks, so you start out and you say, what triangle are D and F both in? And maybe I'll kind of highlight these so I can talk about them. So I can have a yellow triangle, and maybe I'll do a blue triangle. And then the other one we'll just call the big triangle. Okay? So what triangle are D and F both in? Here's D, this length here, and F is here. What triangle are D and F both in? They're both in the yellow triangle. And then what would you call D and F for that yellow triangle? Short leg, long leg, hypotenuse. For this yellow triangle, D is the longer of your two legs. F in that yellow triangle is the shorter of your two legs. Sorry. So now I need to find another triangle where I have long leg and short leg, but remember how F has to be here? So F must be the long leg of a different triangle. What triangle is F the long leg of? F being the long leg. Hey, it's the longer leg of the blue triangle. And so now what goes below is going to be the short leg of that blue triangle. The shorter leg of that blue triangle is E. So we see how that works. We're trying to figure out what fills in the blanks. We got it to work there. Again, geometric mean because F is diagonal from itself. Another geometric mean would be found with D over A. Remember, take a look. What triangle are both D and A in? Here's D, which is part of already just the yellow triangle, and A is also part of that yellow triangle. So once again, these are both in the yellow. What are D and A? Short leg, long leg, hypotenuse. For that yellow triangle, D is the longer of the two legs. A would be the hypotenuse of that yellow triangle. So now for this side of the proportion, A must be the long leg of a certain triangle. Where is A the long leg of? Wait, this side is the long leg of a triangle? Oh, what about the big triangle? A is the longer leg of the big triangle. So now on bottom, I need the hypotenuse of that big triangle. What is the hypotenuse of this big triangle? That would be this entire length, which is called C. Okay. And one more geometric mean. We have sides E and B being compared. What triangle are E and B both in? E and B are both in this blue triangle, it looks like. Now, name them. Are they short leg, long leg, hypotenuse? What parts are they? What is E for this blue triangle? I'd say E is the shorter leg. What is B for this blue triangle? B is the hypotenuse of the blue triangle. So now since B is already here, B must be the short leg of a certain triangle. What triangle is B the short leg of? Well, B is also part of the big triangle, and it is the shorter leg of the big triangle. So to fill in here, I need the hypotenuse of the big triangle. The hypotenuse of this big triangle is this entire side, which is C. Okay, so these geometric means are going to show up in your examples. You don't necessarily need to memorize these or anything. It's just some practice with filling in those variables, and just be aware that this could happen. You could have the same thing showing up twice in a proportion, as you'll see in these examples. Find the variable using geometric means. All right. So here I'm trying to find the variable k. If I'm trying to find a variable, I always just start with it and say, all right, I'm going to pick a triangle that k is in. K is in this triangle here, the little guy, but K is also in the big triangle. I guess it's up to you. I might start with the triangle on the right and say that K and 2 are in the same triangle. Now name them. What are K and 2 for that triangle? Are they short leg, long leg, hypotenuse? Oh, by the way, I forgot my markings, but these are right angles, all of these. Sorry about that. Okay. So what are K and 2 for this triangle? K for this triangle is the hypotenuse, right? It's opposite from the right angle. 2 would be the shorter of the two legs for this triangle. So I'm going to put SL for short leg. Now I need hypotenuse and short leg of a different triangle to go here. For this triangle, I don't know short leg or hypotenuse, so I'm going to have to go with the big triangle. What is the hypotenuse that goes on top of the big triangle? Big triangle, the right angle is here, so hypotenuse is this entire thing, or 10. What is the short leg of that big triangle? Well, here's a big triangle, here's my two legs. The short leg of that triangle is K, and you do have a geometric mean because K showed up diagonal from itself. Okay, the solving part's easier than the setting up. K times K is K squared. 2 times 10 is 20. Undo squared by taking square root. And I have to find the square root of 20, which will be a decimal. K is about 4.47. I'll round to 2 decimal places. Call it good. That seems like a reasonable number for that side length. Okay. Let's try another example here. In this case, you got a person standing, and this is like their line of sight. at a right angle, probably trying to find the height of some object here. Notice where W is, and if I'm going to try to find W, I'm just going to start with that variable anyway. Now what triangle is W in, or what number is in the same triangle as W? I guess I would look at W being in this triangle here. So the only other side that I know in that triangle is the 8.5. So I know I'm going to use that. But I have to identify, what parts do I have? Short leg, long leg, hypotenuse. In this triangle, W would be the longer of the two legs. So LL for long leg. 8.5 in this triangle is the shorter of the two legs. So SL. Now I need long leg and short leg of a different triangle to go here. Well, I already used this triangle here. And now I need long leg and short leg of a different triangle. Actually, don't I have the long leg and short leg of this triangle here? Because the right angle's there? Yes, I have both legs. The longer of the two legs would be the 8.5 for that blue triangle. The shorter of the two legs is 5. And now I can solve for W. Oh hey, it's geometric mean because 8.5 is diagonal from itself. So really it'll end up being like 8.5 squared, which is 72.25. And multiplying this way, I get 5W. I'll divide by 5 on both sides. And I get W equals 14.45. That's exact. And there we go. Alright, one more example here. Oops. Alright, if I want to find H, I'm just going to pick a number that's in the same triangle as H, and it looks like the only triangle I can focus on that has a given side length would be this one. You notice there's no side lengths given in this triangle up here that H is also in. So I'm going to have to compare H with 5. They're both in that green triangle. And then what are H and 5? Short leg, long leg, hypotenuse. For this triangle, H is the longer of the two legs. It looks a little longer than this one. And 5 for this triangle is hypotenuse. So longer leg and hypotenuse. And now I need longer leg and hypotenuse of a different triangle. I don't really have much info on this one, so I must be using the big triangle here. And the numbers I need are long leg on top, hypotenuse on bottom. The longer leg, oh no, I don't have it. I'm noticing I don't have the longer leg of this triangle, and this triangle I didn't have the longer leg either, but I can find this. How about I call this X? The reason I know I can find this is because I have a right triangle. I know the hypotenuse is 25. I know one leg is 5. Now I can use Pythagorean theorem to find this side. Whew, a lot of work here. So I'm going to do hypotenuse squared, which is 25 squared, minus the one leg I have, which is 5 squared, and that should equal the unknown leg squared that I'm looking for. 25 squared minus 5 squared gives me 600. And that equals x squared, and I know I square root to undo squared. Square root of 600 is a decimal. We'll go to 2 decimal places. It's 24.49. Whew, so now I do have the longer leg of this big triangle. It's 24.49, the answer I just got. And the hypotenuse of this big triangle is 25. I'm looking for H. It should be a little less than 5 here. Let's cross multiply, figure out what it is. Here I have 25H equals, and I'm doing 5 times the 24.49. You get 122.47 about, and I'm dividing by 25. And I'm actually leaving all these answers right in my calculator so they're more exact than if I round all the time. My height to 2 decimal places, it's actually 4.898, so then it'll go to 4.90 for my height. And that seems reasonable. It is shorter than the hypotenuse here, and it looks good. So today, looking at the fact that when you have a right triangle and you draw the altitude from the right angle to the hypotenuse, you actually create a set of 3 triangles that are all similar by angle, and you can set up these proportions to find unknown. Just make sure that you are putting, short leg, long leg, hypotenuse. Put those little labels Makes it a lot easier as you're solving for variables.